Hello. Today we're going to have a look at the second key area of the National 5 Physics Waves unit, electromagnetic spectrum, and we're going to answer some past paper questions about it. So, question number 1, a multiple choice question. It says, a student makes the following statements about microwaves and radio waves. 1. In air, microwaves travel faster than radio waves. 2. In air, microwaves have a longer wavelength than radio waves. 3. Microwaves and radio waves are both members of the electromagnetic spectrum. Which of these statements is or are correct? So pause the video here and see if you can figure this out. Okay, so first up, in air, microwaves travel faster than radio waves. True or false? Completely false. They are both part of the electromagnetic spectrum, and therefore they both travel at the same speed, which is the speed of light in a vacuum, 3 times 10 to the power of 8 meters per second. Secondly, in air, microwaves have a longer wavelength than radio waves. Well, we need to be able to remember the spectrum in order of increasing or decreasing wavelength. Now, I remember a mnemonic. Good xylophones usually vibrate intensely, meanwhile tambourines rattle, which stands for gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, TV waves, and radio waves. And that goes from the highest frequency to the lowest frequency, or from the shortest wavelength through to the longest wavelength. So from that, I can remember that microwaves actually have a shorter wavelength than radio waves. So second statement is also not true. The third statement, microwaves and radio waves are both members of the electromagnetic spectrum. Well, that is true. So the correct answer is B. Statement number 3 only is true. Question number 2. The diagram shows members of the electromagnetic spectrum in order of increasing wavelength. Which row in the table identifies the radiations emitted by letters P, Q, and R? Okay, pause the video and see if you can work this out. All right, let's figure this out. So again, I think of my mnemonic. Good xylophones usually vibrate intensely, meanwhile tambourines rattle. And then I try and match these up with the parts of the spectrum shown there. So good is gamma rays. P lines up with xylophones. Xylophones is X-rays. Then we've got ultraviolet radiation, usually. Then vibrate lines up with Q. Q, vibrate, that's visible light. And then we've got infrared matching up with intensely. Then R matches up with meanwhile. So R, meanwhile, microwaves. So the correct answer is P, X-rays, Q, visible light, R, microwaves. Answer A. Question number 3 is a written question. The diagram shows some parts of the electromagnetic spectrum in order of increasing wavelength. A. State a detector of infrared radiation. So, this is one thing that we need to be able to do, is remember a detector and an emitter of each type of radiation. There are a number of these which are given in your course notes or in your revision guide. The one I would use probably for infrared is photodiode and meter. Part B. State which radiation in the electromagnetic spectrum has a wavelength shorter than X-rays. So, going through the spectrum, the only radiation with a wavelength shorter than X-rays, the one with the highest frequency with the shortest wavelength, is gamma rays. See Part 1. An electromagnetic wave has a frequency of 1.2 gigahertz. Show that the wavelength of this wave is 0.25 meters. So I'll pause here and you try and work this out. Okay, this is a show that question. And in a show that question, you must always start with a formula that is on the relationship sheet. In this case, we start with V equals F lambda. Now, this is an electromagnetic wave. Therefore, we should know that the speed of any electromagnetic wave is the speed of light in a vacuum, which is 3 times 10 to the power of 8 meters per second. We're told in the question here the frequency is 1.2 gigahertz, so we can insert these numbers into our formula. 3 times 10 to the power of 8 for V, and 1.2 times 10 to the power of 9 for frequency. We can rearrange that. We get wavelength is 3 times 10 to the power of 8 divided by 1.2 times 10 to the power of 9. And indeed, that does give us 0.25 meters. So we have shown that the wavelength of this wave is 0.25 meters. And finally, C part 2, identify the part of the spectrum that this wave belongs to. So we said its wavelength is 0.25 meters. 0.25 meters is the same as 2.5 times 10 to the power of minus 1 meters. So it fits in between the 10 to the power of minus 2 and the 1 there on the spectrum. It's a microwave. And that, folks, is that. If you want to continue with the waves unit, the third video about the refraction of light is up on YouTube for you to watch now. I'll talk to you again. Bye for now.